Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to talk about the vector part. Here we will discuss especially some basic thing and also we will discuss some mathematical problem. In physics we have learned about two types of quantities. Some quantities can be expressed only by the magnitude with sign plus and minus, and some are denoted by magnitude as well as direction. Dear students, we are going to talk about this all types of math or all types of quantities in this chapter. Let's have a look our today's class. According to our lesson plan, today we are going to discuss about vector, that is your chapter number 12. And here we will first discuss some basic part, especially we will start from the quantity. Actually some quantity can be expressed by only the magnitude, and sometimes we can see the magnitude is not enough to actually describe that quantity. We need the direction also. So among this actually part we can divide the quantity into two parts. One is the scalar quantity and another is the vector quantity. So one is the scalar quantity and another is vector quantity. To express the scalar quantity, only the magnitude will be okay. So if we are trying to focus on the scalar quantity, we will just think about the magnitude. We will only focus on the magnitude with plus minus sign, because sign is very important, with the sign plus or minus. So what does the meaning of the magnitude? Magnitude means the value of the vector. Okay, so at the case of vector, what is the fact? Actually, if we express the vector quantity, we need two things at a time. One, obviously the magnitude, and another is direction. So if these two has worked together at a time, or to express a quantity fully we need these two at a time, then we can understand that actually the quantity is the vector quantity. Let's have a look some example of scalar and vector quantity. At the case of scalar quantity, we can write that length, mass, some example actually. Length, mass, temperature, time, etc. My dear students, if I tell you what time is it now, maybe you can say now it's 10 o'clock or 2 o'clock or something like that. So do you need the direction when you talk about the time? Or if I tell you that what about, can you tell me what's the mass of this marker? Maybe we'll say that maybe it's 5 gram or 10 gram or something like that. You have no needed to express this the direction. Similarly the length, what is the length of the marker? Maybe we will say that it's maybe 6 or 7 or 10 inches or something like that. So no need the direction to understand or to express this actually the quantities for the scalar. That's why we'll say these are known as the scalar quantity, where the value is only needed. But at the case of vector, we need both of that. So we need some example on it also. It can be displacement velocity, velocity, acceleration, force, and also weight, and so on. Maybe here two things at a time has been just problematic to you, that is mass and weight. My dear students, it's really true that for mass it is actually scalar, but at the case of weight you need the what? It is actually a vector quantity. Okay, so if I am talking about the displacement, what is the displacement is? What is the displacement is? If I tell you that okay, the direction like this, that I am just covering 10 meter from Milestone College and actually reached into what? Reached into the Diabari, the Laguna station, say for example. So if I tell you just 10 meter displacement, that means what? In which direction I actually covered the 10 meter. That's very important. So the distance is very important. Say for example, one person has covered from A point to B point. So he has covered up to this point. That's why these types of vector can be expressed by AV vector, and this sign is very important. That means he or this vector actually represents, it is A to B, and here A to B is not equal actually B to A, because this represent as B to A. Okay, so these two actually the different meaning because of its direction, but the value is very much same. Say for example, the distance of A to B is 10 meter. So when it goes that word, maybe it is plus. When it goes that word, maybe for the direction you may say it is minus 10, but here the magnitude always give the positive value. Why? If I am giving you, actually for magnitude we can anything expressed by modulus, and if I write any number in here, we'll get the positive value. If I am going to find out the value for the minus 10, what is the magnitude of minus 10? Obviously it will be 10. So this is actually the magnitude part, or our actually the magnitude represents the value which must have to be positive. Okay, now we'll actually discuss about some very important part, that is support line. What? Support line. What is the support line is? Any vector, say for example an unending straight line. This is an unending straight line, and on this unending straight line, if I give a vector in here, say for example that was a vector from A to B. Say for example this is a vector from A to B, and this vector is lie on an unending line or unending straight line, is known as the support line. So you can say that in any straight line, any part of the straight line is known as the support line. Clear? So support line is also very important for the vector. Okay, and after understanding the support line, we will understand two things at a time: equal vector and opposite vector. These two are very equal at the case of vector definition. That's why I'm writing at the side by side. Just we'll understand what's the basic difference between these two, at the same time what's the real definition between these two. Actually, when we'll talk with the vector which is equal or opposite, that means we need at least two vectors. Say for example, we're going for a vector like this and another vector is like this. What does actually represent these two vectors? Is these two vectors are equal or opposite? What do you think? These are the two things. Here, say for example, this vector is u and this vector is v. Similarly, this vector is u, this vector is v. Okay, to be equal these two vectors, we need three conditions to satisfy. Our first condition is u and v, the magnitude of u and v should be equal. That is the first thing, that magnitude of u and v must have to be equal, and the support line of u and v are the same or parallel. What the support line of u and v vector should be the same line or parallel. So it can be like this, that is these two vectors actually in an unending straight line like this, that is it may be from other one straight line, that is support line of u and v are same line, or it can be the parallel. Okay, and another condition is very important for the equal and opposite, that is direction of u and v are same. Direction of u and v are same. Direction of u vector and v vector are same. So these three condition, if any two vectors have maintained or satisfied, then we can say that two are the equal vector. So when the vector will be the opposite vector, at the case of opposite vector, actually the number 1 rows is same, number 2 rows is same. What same means that the u and v magnitude will be same, I mean equal, that will be the same thing for the opposite vector. Support line of u and v same line of parallel for the opposite vector is also satisfied this. But here it's very important, and the one and only difference between equal and opposite vector are that direction of these two cannot be same, rather it is the opposite. So here this cannot be the same. If it is same, then it will be the equal vector, but if it is opposite, then it should be the opposite vector. So direction of u vector and v vector are opposite to each other, opposite to each other. Okay, so direction are opposite at the case of what? Exactly at the case of this opposite vector. So here these two have the same, yes, the direction is looks really same, but here the direction aren't same, so it actually the opposite vector to each other. If I draw a straight line like this, and if the u vector were going that word, the v vector will become this word. So the direction are opposite, that's why these two vectors are what? Exactly opposite vector. Thank you very much. So we'll go for our next type, that is the vector addition of triangles law. So dear students, now I will actually discuss a very vital and important rule in our vector sector, that is what's the triangle law of the addition of the vector. To understand the triangle law, we'll first understand one thing, that is what's the addition of the vectors. How we can add two vectors. To add two vectors, we will saw a triangle first. Say for example a triangle like this. This is a right angle triangle, and in right angle triangle the very important thing, where and in which direction the vectors are working. Say for example our vectors are working like this word. Okay, this has been actually going that word, and in this line it going this word. So here if we are thinking this is the pipe of the water, then we can say the water actually going this word and that word. So how the flow should be the going on? The flow should be like this and that, but not. If any vector just protect the flow, if any vector protect the flow, then that vector is equal to the addition of these two vectors. Say for example this is the vector of u, this is the vector of v, and the flow of u and v has been restricted by this vector. That's why we can say this vector is u plus v vector. U plus v vector, and we can write it like this way because vector can be actually expressed by some way. Vector can be expressed by this way, it can be expressed by that way, it can be expressed by like this way, it can be also given by this way. Okay, so these are the ways actually we can express the vector. So no problem, here was the u vector, here is the v vector, and this vector has been restricted by this two, that's why this is the equal. And in our triangular law we have been said the same thing. If the flow of the two vectors has been restricted by one vector, then this vector should be the addition of that two vectors. Now let's have a look at example for you. Say for example, this is another triangle for you, and in this triangle, if I'm talk about this two is going this word, and here it has been restricted the flowing. So this has been going the same word, but it has been restricted. So we can say if it is x, if it is y, so this vector should be x plus y. Clear? So this is very simple rules for the triangular law of the addition of the vector. Clear? Now we'll saw the addition of the vector at the case of parallelogram, that how it looks like at the case of parallelogram. So dear students, now we'll discuss about the parallelogram. What actually the parallelogram work and where the parallelogram actually working. To understand the parallelogram, we have to understand two things at the very beginning. That is, say for example, from this point, one line or one vector actually goes this word, okay, and another vector, say for example, is going that word, okay, going that word. So say for example, that is our v vector. So what will be the diagonal of it? What will be the diagonal of it? It's maybe something little bit trickier for you, but don't worry, I am going for the parallelogram first. Say for example, that was the very common parallelogram for us, and we know these two sides are equal and this side is also equal, and we have already known these types of parallelogram has two diagonal, this and this. So here actually talk with that this is the line, it is actually represents by a vector, and this line is represented by another vector. We have to find what? We have to find the length of the diagonal. How we can go for it? If this is u and this is v, so if I draw a line like that way, then if this is v, then the magnitude of that also must have to be v. And if I join these two lines, so this will be our what? The diagonal. If we add this also, so this is u and this is v, and here forget about this part. If we forget about this part, can you tell me what is the value of that? Exactly, thank you very much, you have understand very clearly, because the flow of going this word then that word, and this two flow has been restricted by this part, that means that must be u plus v. So if it was a parallelogram and two vectors are given here, then we can say the two adjacent side, if it is even v, then these two resultant or the diagonal should be the addition of that two. That's the parallelogram law of the addition of the vectors. Very clear, and I think it is very easier for you. Exactly. And what about the subtraction? Subtraction is nothing but the addition. If you have the focus or you have the clear idea about the addition part, then no need to understand about the subtraction, because say for example that was u or v, that was u and this was v. So what about this? Actually this was the biggest part and that was the smallest part, so this must have to be v minus u. Okay, because this way, because that and these two are the same part and this was not the same part. If I am going for the naming of that part a, b, c, then you should have to write like this. You should have to write AC vector equal AV vector plus VC vector. So what about the AC vector? Here AC vector was V, AV vector was U and VC was there. And what about the VC vector? V vector minus U vector equal to VC vector. So this is nothing but the addition and the equation solution part. So I think you can understand the subtraction also, and my suggestion you to that don't understand about the subtraction, don't worry about the subtraction. If you have the sound knowledge of addition, I believe no problem with the vector part. Okay, let's have a look our one last definition, that is what is zero vector. What is zero vector? If any vector's magnitude or the magnitude of any vectors is 0, then this is called the zero vector. Clear? So the magnitude of any vector, if it is 0, the value of the vector is 0, then we can say this is zero vector. Very clear? Okay, let's have a look our last part, that is one. So this is the last theorem for our today's lecture. Actually, dear students, our last theorem or the theorem is related to our example 3, and this question actually is talk about with the help of the vectors. Prove that the line segment joining the middle points of two sides of a triangle is parallel and half of the third sides. So what actually talk about in here? Here is talk about we'll going for a triangle first, and this triangle has two midpoints for two adjacent sides, and if we join the 2 points, then that points actually the making line of the two joining points will be the parallel of the third side, and that will be the half of the third side. So let's have a look what actually talk with here. Maybe we can think that this is our triangle of ABC. Okay, and in this triangle our 2 point or the midpoint of AB and VC, say for example D and E. Okay, so first we can denote it like this way, that we have to describe, let D and E be the middle point of the side AB and AC. Let D and E are 2 points or 2 middle points of the side AB and AC, which are the side from what? To triangle ABC, of triangle ABC. Okay, we have written it, just first part. Then if we join these two, then what will be happen? And here first thing first, since we have talked with AB and AC, so it should be going that word. AC, that means it should be going this word. Okay, since we have talked with AB and AC, we can write, since we are just think these two are the sides, that's why we will not use here the vector sign, but when we work with the vector part, then we'll use that vector sign on that time. Okay, so here joining 2 points, join EF or ED. So what we need to prove? This actually parallel to the third side, half of the third side. So we need to prove that or it's required to prove that what this D is parallel to BC. Since we have talked with DE and BC, so this two must have to be going that word. And another proof we need to have to, that is D will be the half of the third side. So here actually this BC will be half of DE. So these two things we have to prove in here. So how we can prove these types of problem? Okay, so to prove these types of problem, first of all we will think about this smaller triangle. So from triangle ABC, actually ADE, what we can write? Very clearly we have to see the flow has been going this word, then that word, and this has been restricted. So we can say AE is equals to AD plus D. Clear? Is there any confusion? I don't think so. Thank you very much. So here we can say that the D should be what? The D should be AE minus AD. And give it equation number 1. Now we'll work on the total triangle in here. So from triangle ABC, what we can write here? AB BC going this word, that word, and it has been restricted. So what we should have to write? Exactly, AC equals to AB plus BC. Isn't it? Okay, so here the AB can be written as 2 into AD. Why? Because we have already known D is the midpoint. That means these two parts actually equal. Similarly, these two parts are also equal because E is the midpoint. So we can write actually at the place of AC, we can write AE plus EC. Or we can write 2 into AE at a time. 2 into AE at a time, because AE and EC are same. So 2 into AE. What about AB? That must be 2 into AD. And BC will be remain as usual. So if it just changed its side, so 2 will be common, then it should be AE minus AD is equals to BC. So AE minus AD is nothing but the D. So 2 into D is equals to BC. So what we need to prove here? We need to prove that VC is equals to 2 into D. So here we have observed that 2 into D, that means we can say D is equals to half into BC. So if you write like this is the proof, then okay, this will be also the proof. But one thing we have to prove right now, that is these two are the parallel. Here just you have to actually write two comments. Which comments? We have already known the support line. Support line must have to be the same line or the parallel line. Do you think these two have the same line? No, these two are not the same line. So must have to they are parallel. So we'll write that comment, that the support line must have to be the same line or the parallel line. Since these two are not same, that's why these two are parallel. So D is parallel to BC. So hence we can prove this theorem very clearly. So dear students, that's all for today's class. Hopefully this lecture is very beneficial to you. If you have any problem in any time, no need to hesitate to call me. Thank you.